All right, here's the first video of the first example of section 8.4. Now, in 8.2 and 8.3, you learned how to find the sum of finite series. The first one was arithmetic, and the second one was geometric. But we haven't really discussed what happens if we're trying to find the sum of an infinite series. Now, a lot of people might think, well, that series goes on forever. There's no way to add it. It's just going to approach infinity. So when you add up infinite numbers, it's going to equal infinity. And that is true, but not in all cases. Now, I'm going to show you some cases where we have an infinite geometric series, but we can actually take the sum of it and find the sum. So in this section, we're going to learn how to determine, first of all, if you can take the sum of an infinite geometric series, and if so, how you do that. So let's look at these first problems right here. We've got three examples. So the first one, you see that we have our summation notation, and our lower limit is 1, and our upper limit is infinity. So this is a geometric infinite series. Now, before we try to do that, let's figure out when we can take the sum and when we can't. So let's go look. I'm looking at the journal in section 8.4. Now, you see right here, the core concept is we can take the sum if and only if, right here, if our ratio is less than 1. Now, that's the absolute value of the ratio. So what that means is if both negative r and positive r are less than 1. Now, if r is greater than 1, so if the ratio, if either negative or positive r is greater than 1, then we can't take the series. And it has no sum, it just approaches infinity. Now, you see right here, our formula is pretty simple. Our sum is just our first term over 1 minus r. Now again, this is the important part. We have to make sure that our ratio is less than 1. What that means is that basically our ratio has to be a fraction or a decimal. If our ratio is a whole number, then we can't take the sum of that. So let's go back and look at the examples. Now, in this first case, we see that our rule is 3 times 0.7 to I minus 1 power. Now let's go ahead and walk through that step by step. Now if you look right here, we examine our geometric series, and we see that our r value is equal to 0.7. And we see that we write the general rule for our sum. So we see that if we plug in our first term, so if we take I equals 1 and we plug that in for our first term, we get 1 minus 1, which is 0. So we get 0.7 to the 0 power is always 1. 3 times 1 gives us 3. So our first term is 3, and our ratio is 0.7. That means that we can find the sum. Okay? All we have to do is plug in our first term and our ratio, which in this case is 0.7. So what you have to do, first of all, you have to determine if your ratio is less than 1, so the absolute value of r. If that's the case, all we do is just plug these values in for our general rule, and we go ahead and solve. So our sum is just 3 over 1 minus 0.7, and now we're just plugging this into a calculator or doing this calculation. We end up with 3 divided by 1 minus 0.7 is 0.3, so 3 divided by 0.3 is just 10. So in this case, our sum is 10. Now let's look at our next. So we look to find our common ratio. So remember, our first term is 1, and our second term is 3. So the common ratio is just our second term divided by our first term. So we get 3 over 1, which is 3. Now, this is greater than 1. Now our rule, again, if you go to our rule right here, if the absolute value of r is greater than 1, which in this case r is 3, So 3 is greater than 1, the sum does not exist. It's as simple as that. If our common ratio is not a decimal or fraction, the sum does not exist. So you've seen 2 examples here. Let's go ahead and look at one more. Let's look at the third. Now, let's see. We have to find the common ratio right here. Now, we're already told that each of these are geometric, so we don't have to determine if they're geometric or not. Now, remember, if this said determine whether these sums are geometric series, if so, find R. So we already know these are geometric. That's why we're just taking one term and dividing it by the first. If we had to determine if they were geometric, we would have to do this a few more times. So let's go ahead. We take our second term and our first term, so negative 3/4 and 1. Negative 3/4 divided by 1 is just negative 3/4. So when we look at our first term, it's 1. Our common ratio is negative 3/4. But remember, the way we find our ratio is we have to see if the absolute value is less than 1. If we go ahead and plug that in, we get that it is the absolute value of negative 3/4 is less than 1. So we can go ahead and find the sum. Again, write our general rule. So A1 over 1 minus R. In this case, R is negative 3/4. A1 is 1. This is very simple. This is just finding a bunch of terms and checking with our rules to see if they satisfy the rule or not. Let's just plug in A1 and R. So we're going to get 1 on top, 1 minus 3/4. So here we go, 1 over 1 minus negative 3/4. So we're going to get 1 over 1 plus 3/4. When we do that, we get 4/7. That's all we do for our sum. Very, very simple. So I want you guys to practice this right here. So you guys have 3 examples that are just like the ones we just did. Remember, I'm emphasizing that because if you have any questions, please go back, watch the video. We did examples just like this, where we calculated R, and then we looked at what our first term was. We saw if R was less than 1, the absolute value of R. Then for these ones, we already have A1. You get your R by using the first 2 terms. It already tells you that it's geometric series. On our third one, we have A1. This is not rocket science. This is very simple. Go back and watch the examples. I don't want anyone saying, I don't know or I don't understand. We literally just did the same problems. So please, go back and watch. All right? Go ahead and do these 3 problems. I'm going to put the same text box. Just write it when you do the text box. Make sure you label these A, B, and C. You're finding the sum for each of these.